We have seen more than 10 problems based on permutations and combinations, and we have used logic to solve all of those. Once we understand the logic, there is no harm in using the formulae, which we will see in this session. We know that permutation is about arranging things, and combination is about selecting things. But we need to get a deeper understanding of this. Is it extremely easy to figure out the difference between arrangement and selection? Before we get to a few examples, let's understand the notation. If we have to arrange R things out of N, it's written as NPR. Arranging R things out of N. We use P as its permutations. And for selecting R things out of N, we write it as NCR. C for combinations. Let's zoom out and discuss each of these in detail. Permutations is about arrangement. But what does this arrangement tell us? What is it that explains this word? It tells us that the order matters. The order in which the things are placed matters. ABC and ACB will be different. 1, 2, 3 will be different from 2, 3, 1 and so on. And what about combination? Combination is selection. Selection is simply picking a few things. Here, the order does not matter. Say from the digits 1, 2, 3, 4, 5, we picked up 1, 3 and 4. Picking up 1, 3, 4 is the same as picking up 4, 1, 3. They are not two different cases. Let me give you a permutation example. Assume we have to pick a team of 3 people out of the available 10. One of them will be chosen as a vice president, another as a manager, and another as a product developer. This is a classic case of permutation. The order matters. If we select A, B, and C, then it can be a case of VP, manager, product developer. Or maybe A is chosen as a product developer, B as vice president, and C as a manager. Each case is different. On the other hand, if we are asked to select a leadership team of 3 out of 10 and told nothing else about it, then it is a case of combination. The order does not matter. Selecting A, B, and C is the same as selecting B, C, and A or C, A, and B. Take another example. Say 2 out of 5 people get ice cream. One gets vanilla and the other gets chocolate. This is a case of permutation, as each of the 2 people selected may get either vanilla or chocolate flavored ice cream. And if we are just told that 2 out of 5 get ice cream, it will be a case of combination. We aren't told anything else. Just that 2 out of 5 get ice cream. So the order clearly does not matter. Now that we have understood what permutations and combinations are, we can move on to the formulae. First, we look at NPR. Arranging R things out of N distinct objects, and repetition is not allowed. For example, let's assume we have digits 1, 2, 3 and 4. And we have been asked the number of ways in which we can form 3-digit numbers using these 4 digits. For this formula, we cannot consider cases such as 111 or 232 or 441. The digits are repeated in each case. So the objects have to be distinct and there can be no repetition. So this equals n factorial divided by n minus r factorial. Yes, that's the formula. If we have to arrange 3 people out of 10, it will equal 10 factorial divided by 10 minus 3 factorial. Don't worry, we will look at numerical examples later. For now, let's just look at the formulae. We move on to combinations now. NCR. It's selecting 3 things from 10 distinct things. This will equal n factorial divided by r factorial times n minus r factorial. Yes, that's the formula for combinations. If we have to select 2 out of 5, the number of ways in which it can be done is 5 factorial divided by 2 factorial times 5 minus 2 factorial. At first, these formulae look scary, but as you start practicing, you will see that using these formulae gets us the answer really quick. Now that we have seen the formulae for permutations and combinations, let's see how we can apply them. We will see two basic cases. First, when we have to select 3 out of 5 distinct objects. Remember, 5 distinct objects. And second, arrange 3 out of 5 distinct objects. Let's understand the select case first. Selecting 3 out of 5 distinct objects. For the 3 objects that we have to select, we make 3 slots. The first slot can be filled in 5 ways. Any one of the 5 digits can be selected. After 1 is selected, 4 remain to be chosen from. The second number can be picked in 4 different ways. And as 2 are already picked, 3 remain from which we can pick the third one. 3 ways. But as we have been asked to select, the order does not matter here. And as the order does not matter, we divide this by 3 factorial. So 60 over 3 factorial is the number of ways in which we can select 3 objects from 5 different ones. We have seen this logical approach in the previous sessions. Don't worry and be patient. We will come to the formula shortly. There was another approach we had used to solve such problems. Let's say we number the 5 objects as 1, 2, 3, 4 and 5. From these 5 objects, we have to select 3. We can select any 3 objects and put them in the S category. And as the other 2 are not selected, we put them in the NS category. There are 5 factorial ways in which we can arrange 5 different objects. As 3 of them are in one category, we divide this by 3 factorial. And as the remaining 2 are in another category, we divide it by 2 factorial. This will give us the same answer as this one. Now we come to the formula. As we just have to select, the question of arrangement does not arise. It is a case of combination. We can use the Ncr formula, selecting R things from n different objects. As we are selecting 3 out of 5, this will be 5C3. The formula for combinations is n factorial over r factorial times n minus r factorial. Here, n factorial will be 5 factorial, r factorial will be 3 factorial, and n minus r factorial will be 5 minus 3 factorial. This will also give us the same answer. Here, we simply use the formula we knew. In the other 2 methods, we use some logic to get to the answer. Of course, if you remember the formula, you would get to the answer quicker. But understanding the earlier methods would help you in 2 ways. First, if you forget the formula, you would be able to apply these concepts. And second, modifying the question slightly wouldn't stump you. So make sure you understand the concept and then you would definitely know when to apply the formula. And remember the golden rule. Don't memorize. In the next part of the session, we will see the number of ways in which we can arrange 3 out of 5. In the previous part of the session, we had seen different ways in which we could find the number of ways in which we could select 3 objects out of 5 different objects. In this part, we will look at arrangement of 3 objects out of 5 distinct ones. As we plan to arrange 3 objects out of 5, we can make 3 slots for them. The first slot can be filled with any one of the 5 objects. It means there are 5 ways in which we can pick the first object. After one object is picked up, just 4 remain for the second one, and 3 remain to be chosen from for the third one. As the order matters, each arrangement will be different. So we don't divide this by 3 factorial like we did before. So these many ways in which we can arrange 3 objects out of 5 distinct ones. Another way to look at it is by numbering the objects from 1 to 5. In the previous case, 3 were selected, and as their order did not matter, we put each of them in the S category. But here, the 3 objects have to be arranged. So we need to put the 3 selected objects in different categories. The 3 different categories could be labeled A, B, and C. As the order matters, A, B, C will be different from ACB or BAC. And what about the two objects that are not selected? Should each of them be put in different categories? No, they should be put in the same category. If these two are not selected, we can say that 4 and 5 are not selected or 5 and 4 are not selected. It doesn't matter, they mean the same. Both are not selected. So we can put them in the NS category. Now that we have made the categories, we can calculate the number of ways in which this can be done. 5 distinct objects can be arranged in 5 factorial ways. And as 2 out of these 5 are in the same category, we divide this by 2 factorial. This will also give us the same answer, 60 ways. And we also have to formula to find the number of ways in which we can arrange 3 out of 5. We can use the Npr formula. We use permutation as we have to arrange the objects. Arrange R objects from n distinct objects. It equals n factorial over n minus r factorial. Here, as we have to arrange 3 out of 5, it will be 5p3. Based on the formula, it will be 5 factorial divided by 5 minus 3 factorial. This will also give us the same answer. So by now, either using logic or using the formulae, you should know the different ways in which we can approach any problem based on permutations and combinations.